Alright, so here we have an example of how you will be building your circuit for the digital circuit class. First of all, we use breadboards. Okay, I think some of you have already seen the breadboard, the white board you see here, and we'll be basically building all the circuit on top of the breadboard. Okay. Now, to build the circuit, what do you need? You will need ICs, right? You will need the IC, you will need some wires, and you will need LEDs like this. Okay, they will light up based on your output. For an example, if the output is 1, it will be light, you will see the light, and there will be no light if the output is 0. So sometimes you want to check the output, you will connect the LEDs. And also there will be some kind of switch package like this, which is called dip switch. Now, if you look at carefully, let's look at how you basically install the ICs. Look at this. At the so first of all, in the breadboard, all the columns here are short. Okay. So maybe I can show you another image from here. Give me just a second. All right. So if we look at this part of the breadboard, look at this. We marked here in the green. Basically, all these columns are short. You see what I'm saying? All the columns. We mark the columns here, but you know, all the columns are basically short here. In these blocks, all the columns are short like this. So for an example, all the points in one column is basically the same point. You see what I'm saying? Even in the top block here, we have all the columns short. And in the very top row, here in the rows are short. At the very top, these are called RAID. Okay, some people call it RAID. Okay, so here all the rows are short. So you see here, we have 2 rows at the bottom. We have 2 rows at the top. Most of the cases we use those rows to get the VCC, meaning 5 volt, to get the 5 volt, or to get the ground, because you know the most of the ICs you will be using, they will require voltage 5, they will operate on voltage 5, and also they need a ground connection. Okay, so just again, before we move on to the next image, any breadboard you will have all these columns short, but remember these points are not short. Okay, this block is not short with this, but in this block all the columns are short. Okay, in this block all the columns are short. In this block these 2 rows are short. Okay, look at this, how we mark the green ones. Similarly, this row is short as well. In the top 2 rows are short. So short means they are basically same point, but you know you have bunch of holes, because so that you can extend your wire and connect them. Okay, now let's go back to the previous one, see what you have here now. So what we are doing is, if you look at carefully, let's say these are the you know the ICs, right? But you know the ICs have pins, right? But there is a certain way of reading the pin. If you look at the IC, you will see carefully that in one side there is a little curve here. That's basically, you assume that is your left side, and then you start reading from here. So this is going to be the pin number 1. Okay, so if you keep it in your left side, that little curve there. Okay, so what we are saying is, if this is the left side, so this is going to be the pin 1. Okay, and then you start reading from here. So this is pin 1, pin 2, pin 3, 4, 5, all the way to the 7, and then you go to here, that's 8, and read backwards 9, 10, 11, 12, 13, 14. That's how exactly you will read the IC numberings. Okay, and look at how we are installing the IC here. You keep your curve in the left side, and you are basically putting here in the middle, because you don't want all these pins to be short with all these pins, right? So that's why you do it like this, so that all the pins at the bottom are basically can be connected through these columns, right? and all the pins at the top can be short or can be connected to something else, some other pins. And also similarly you use a dip switch here, which is a switch package. So we'll talk about the dip switch a little bit later, but let me show you something here. So let's say you are trying to connect. If you look, do you see this wire here? Can you tell me which two pins are connected through this wire? Look at this. This wire started from pin 3 here, right? So this wire basically connected the pin 3 and pin 1 of the another IC. Okay, do you see it? I'm just showing you how you connect things. Okay, and all right. So, and interesting is you also want to use the switch. Now the reason we use switch, because in the digital circuit what happens? You work with the digital circuit, right? I'm saying in page and paper. So you have seen in a digital circuit what do? We give different inputs. Sometimes we give 1, 0, right? So how do you give those 1s and 0s? Using the switch here. Okay. So in this switch, you will see if you push this way, it will be top side, it will be 0. This will be 1. And look at carefully, the switches are also connected to your ICs. Do you see it? For an example, look at this. Look at the switch 1. What we did? We ran a white wire up to this point, and then again we ran a yellow one up to here, because that's how we are connecting white and yellow are connected, right? Do you see that? Because the point white ended, yellow started from the same column, because everything in the same column are short, right? That's what I'm saying. So the yellow one, the white one, and the yellow one are basically connected because they're in the same column. Do you see they're in the same column? It's hard to see the color maybe, right? I'm talking about the here. Look at these two points. These 2 points are short, right? I'm saying all the points here are short. I'm saying all the points in the column are short. So the white wire stopped here, right? And then yellow one started from here. So basically they are connected. Okay, now here in this block where the yellow one stopped, you started the chocolate one from the same column. So basically white, yellow and chocolate, they are right now in one single wire basically. Do you see it? The reason I'm showing you this because just to see how you can connect things. Basically the white one, yellow one, and similarly if you look at the other white one, this is connected to this yellow, because what happened, this one stopped here, you connected to this point, and then from the same column you started something again, which is the yellow one, and then you stopped the yellow one here, but you started the chocolate one here. See, everything you have in the same column, they are basically same connection. Okay, so what you are doing, you are basically connecting the switch one to basically, look at this switch one is going to pin 1. Do you see it? Switch 1 is basically connected to the pin 1. Do you see that? And switch 2 is connected to pin 2. Sure.
You said the switch 0 was up.
Yeah. I would say up is 0. See, these switches, it can be up and down. If it is up, that means 0. Logical 0. We know in digital circuit we always talk about the logic, right? Either 0 or 1. Up is 0, down is 1. Okay. But here, see, we are just trying to show you that how you connect things here using the breadboard. Why the breadboard is so useful. Okay. This is already in the pause, so you will get all this information. Remember, all the labs, we have bunch of images and pictures and things, and that will really help you, because for each and every lab we have a schematic first of all, where we draw the gates. Okay, but in the real circuit you don't see the gate, you see the IC. But for each IC, we'll give you the lab manual. I know that some of you probably have the lab manual, but some of you don't have. So in the IC, Remember, we showed you one slide. I can go back to that one, but where we have all the ICs, and inside the IC you have those small gates. So for an example, if you it's not visible here, but in the IC the numbers are written. Okay, if you see 7400, it will not be like 7400. There will be like 74 and couple of capital letters like HC and then 00. Okay, that means that is a NAND gate, because all the 7400s are NAND gates. Okay, now for every gate, every IC, you have a pin configuration. So you will exactly know which pin is what from there. Okay, for an example, if I go back to that slide, just that part, let me show you that. All right, here I was referring to this one. You know, we will show you the data sheet. We'll give you the data sheet. There are data sheets at the back of the lab manual for each and every IC you'll be using. Now, let's say for an example, this is the 7400, the top left one. That's the 7400. Now, you will know from here which pin is what. You see what I'm saying? Let's say the pin 1 and pin 2 are the input, and pin 3 is the output. So basically, let's say you have a circuit, okay? And in that circuit you have like 3 NAND gates. How many IC you need? How many 7400 you need? Okay, you need 7400, right? Because 7400 is for the NAND gates. You see, the other ones are for different things. You know, every IC has different logic gates. So since you need NAND gates, you know you will need 7400, right? Now, how many 7400 you need when you have 3 NAND gates? You just need 1 IC. Because look at this, in 1 IC you have 4 NAND gates. Even if you need like 4 NAND gates, you just can work with only 1. Okay. Now, if you look at ICs, all of the IC, look at carefully, something is very common here. Look at the pin 14. It's written VCC. That means that should be connected to the voltage 5. And the pin 7 should be connected to the ground. I'm saying the common ground, which is voltage 0. These 2 pins must be connected like this to make the IC working, to operate the IC, okay? But be careful, these are only true for our ICs, but there are several ICs in the world, they have VCC and the ground, which are not in pin 7 and pin 14, okay? So before you connect those things, you must always want to check with the data sheet. Because every IC may be different, and you know, some IC might have like 16 pins. Some ICs might have 24 pins. It doesn't matter how many pins you have, as long as you know the data sheet, as long as you can read those, understand these, okay? We can understand all of this, I'm sure, because we know the logic gates, we know how they behave, right? How the logic gates work. So, again, we'll have the data sheet, we'll know it from there, and we'll also know which IC to use, because this is one example here. For an example, let's say you need inverters. Which one you use? 7404, right? All the inverters here. Do you see the inverters? See, so you know, for an example, now let's say you need only 1 inverter in your circuit. So, but still you have to use the whole IC, right? So in the whole IC you have 6 inverters. You see, there are 6 inverters. 1, 2, 3, 4, 5, 6 inverters here, right? So which one you want to use? You need just 1, let's say. You can use any of those. So there is no ordering that, okay, you have to use the first one. You can use any of those, but make sure you use, you know, right input and output. Let's say you can either use 5 and 6, because 5 is the input, pin 5 is the input, pin 6 is the output. So you can either use this pair, or maybe you can use this pair. Which one you want, you can use that, okay? So what do you do is, when we have a specific digital circuit, okay, I think we all saw the digital circuit in the page and paper, right, when we answered the digital circuit. So before we build the circuit, at very first, what you do is, we basically write their pin numbers, so that we exactly know where to connect to what. I'll show you how it looks like, okay? I'll show you that. Let me show you a couple of examples. Let's see whether I can find some good examples here. Let's see. If you look at the pause here, you will see for each lab we have a section here. Okay. For an example, lab 3, these are all the materials you have. Now, what are these materials? So let's say this is the schematic. Okay. So you will need the schematic for sure. Look at the schematic here. What it is telling you that you will need the yeah, 7400. That's the NAND gate, okay? NAND gate, and that's the inverter, okay? Okay, and then you see here there is a resistance, I'm saying the register 220, and there are two 220s here. So basically, and there will be an LED here, Now, look at carefully what do you have here. Do you see this 1, 2, 3, 1, 2? These are basically the pin numbers. So before you start working with that, you will have to write those pin numbers. Because once you have the pin numbers, you exactly know what to do. For an example, you know that from the pin number 3 of 7400, you have to run a wire up to the pin number 1 of 7404. Do you see it? This line. Yes. And you know how to connect them, right? In the breadboard. Listen what I'm saying? So exactly that's what we are going to do, okay? We read the schematic and we'll see it from there. And also a couple of things from here. So you see these A and B, they are the switch. So now the deep switch, you have like 8 switches there. Now which one you want to use as AB? Doesn't matter. Just pick any two. Okay? And then on off, those configuration will be coming. You know, when you have 2 inputs, how many combinations you can have? 4, right? 0, 0, 0, 1, 1, 0, and 1, 1. So you'll be basically building the circuit, and once you build it, you just, you know, change those switches and record the result. And then, what do you have? You now have a truth table, right? We all know the truth table. And every circuit, in digital circuit, every digital circuit will have a truth table, and from the truth table we will know exactly whether the circuit is working right or wrong. For working correctly, every single row has to be right. If something is not working, whole circuit is not working, somewhere something is wrong, we have to figure it out, and there is a certain way of figuring it out, okay? We'll do it in the next step to show you how to, you know, debug the circuit. That's really important. Because once you build the circuit, it may not be working, something may be bad, register may be bad, connection may be wrong, pin may be wrong, IC may be bad. How do you know it? You cannot know it just looking at those, okay? So let me show you some of the extra information here, okay? Let's go back to here, okay? Now, couple of things. When you see that, okay, here we are using the switch 1 and 2, right? We needed 2 switches out of 8. We are using only 1 and 2. Now what we did for 1 and 2, look at this. In the 1, in the top, we are basically shorting this 1 to the VCC, because this is the row for the VCC. Now how it is a row for the VCC? Because we always keep this row for the VCC, and we always keep the last row, because you know, this row is short, right? The top one, row is short. The whole row is a single point basically, okay? And the bottom row is a single row. So what we do is, we use the top row for the 5 voltage. When you go to the lab, you will be just running a wire from any of this point to 5 voltage from your station, okay? So that means this whole row will be used for VCC. VCC means 5 volt. Yes, because most of the ICs in this class will be working on voltage 5. Okay, and the bottom row will be connected to the ground, which is voltage 0. So whenever you are using some switches, what you do is, here you have to run a register. Do you see there is a register? It's 220, okay? Most of the cases there's 220 in this class. It's a 220 register which we use to short Okay, short between the switch and, look at the switch and voltage 5, and then you run a wire here to short it. So for each and every switch you will be using, you have to do this. So we are using 2 switches here, so that's why we did it for only first 2 columns. You see it? So if you go back to the image, oops, where is that image? Here, those ICs are here. You see here, there is a register here. So those were basically the top 2 registers, R1 and R2. Okay? And you see this is a ground. It looks a little bit different, but that is the same connection basically. So for each and every switch you will be using, you always have to do this. You have to connect the top of the switch to the, basically you are powering up the switch. Because by changing the switch you are giving 1 and 0, but how that 1 is coming? That's a voltage, right? I'm saying logically there is 1, but technically there is a voltage. So that voltage should be coming from somewhere. So you are connecting the switch to the power, let's say. Okay? So you always have to do that. Doesn't matter which switches you want to use. You might, at some point, you might have to use all the switches, but not right now. And also, if you look at the ICs carefully, you see, as we said, the pin 7 has to be grounded. Look at the pin 7. For each IC, you see, we grounded those IC. You see here, this is just a wire we ran to make it short to the ground. You see it? And also, for each pin 14, this is pin 14, right? Each pin 14 is also connected to the voltage, which is VCC here. Because, this column is short, right? So you can just run a wire from any of this point. So, these are some ideas. So this picture is already there. It's under the tutorial section of the pause content section. So, this is just a snapshot of what you are going to see and how you are going to work. But remember, in case of the dip switch, we connected the dip switch to pin 1, right, and pin 2 here, right? But we used 3 different wires, right? The white one, followed by the yellow one, followed by the chocolate one. But you don't have to use 3. You could have just directly connect here to here. I'm saying only using 1 wire, you connect it from here to directly here, okay? Just from the, but sometimes we don't want to do that because we want our circuit to look neat. So that's why we want our wire to be as short and compact as possible, because that's really will be helping you out when your circuit will not be working. Because if you will have plenty of connections, but you don't organize it like this, what might happen? It will look like a big hill at some point. It will be a messy thing, and when you have to debug, let's say something is not working, plenty of things will be there, because otherwise, like this, if you have something like this, it's really, really clear to see how the cables or wires are running, okay? And it's really good because this is a very simple one, and most of the circuit after this point will be, over the time it gets bigger. You will have more connection, and more connection. But also here in pause, let me show you a couple of more things. In the pause, for each and every lab, you see there are a bunch of things here. So what are those? For an example, if you click lab 3A image, okay, with power connections, let's click it. It might take a while to come here. Oops. Let's refresh it. Now look at this. There is an image for each and every lab. What you do is, we give you the schematic first, okay, so you know exactly which pin to be connected with what, right? And also, we showed the connection in an example, okay? I'm saying these are for your help. But remember, let's say we are using this column here, right? But you can use another column for sure. You know what I'm saying? For an example, you don't have to use the IC here. You can move it further down to the right. Don't assume that it has to be exactly like this. As long as the connections are right, This is an example of how you connect your circuit, okay? This is for lab 3A, for an example. Similarly, for each and every lab, we gave you the image. We give you the schematic so that you will know exactly how the circuit is connected, which pin is connected to which pin, and then also we give you the image for each and every lab so that you will know exactly how it should, this is an example so that you can just follow the example and build your own circuit, because this is exactly the same circuit, but you can move it a little bit around and, so look at this. Look at these registers here at the top. You could have started it from this pin, right? Doesn't matter. I'm saying all the pins are same, right? You see what I'm saying? You could have started it from here instead of here, because all the pins are same, so it doesn't matter. As long as you understand how to connect it, this is a sample, it should be working. And also, sometimes you'll see there are LEDs. Not sometimes, it's probably almost all times, you'll see the LEDs. The reason we use the LEDs in the circuit. I'm saying one column is short, right? Because doesn't matter which holes you are using. Yeah. In one column, doesn't matter which holes you are using, because all the holes are the same. It doesn't have to be in this order. You see what I'm saying? Let's say the wide one started from here, right? It could have started from the top hole. I'm saying it doesn't matter. So don't assume that it has to be exactly like this, as long as you understand the connections, okay? And also, do you see there was a short at the bottom? I said, remember, the switches you are using, those have to be, we are using switch 2 and 3 here, let's say. Not 2 and 3, it's 3, I'm sorry, 3 and 4. So those has to be short here as well. Okay, and the register has to be here, and then look at this, how we are running the, I tried to take some neat picture. You can also be, again we did the same thing. We ran the 3 wires to connect the switch to the pins, but we could have run only 1 wire. I just want to make it a little bit neat, and you will have needle nose plier and cutter stripper, so use those to push the wire and also cut it, make it small. There will be a bunch of wires, so, and try to reduce the waste. So if you have a small wires, you can keep it for the next circuit, so you can build the next ones. And also, look at the output side. Let's say you want to check the output. What we did? We run the wire. Let's say we want to check pin 2, okay? Pin 2 of the IC2. What we did? We run a wire from here to here, another free column, okay? So let me show you here. What we are doing, we are running the wire from here to here, and then through the register, we connect it to a LED. Do you see it? What is the reason? What is the purpose? Because we want to see what is the output, or what will be the output of the pin 2. How do you know the output? Because if you connect the LED, what happens? If the pin 2 is high, LED will light up, right? If it is not high, low, there will be no light. So from there, you will be able to record the result. Because otherwise, if you don't know the result, what is the purpose then? Okay? So similarly, when you go to the, excuse me, if you go to the schematic, if you look at the schematic, you will exactly see the same thing in the schematic as well. If you look at the schematic, look at this. You might be wondering that how the LED come into the picture. Look at this. With this point between pin 3 and pin 1, we basically ran another wire through the register to the LED. Do you see that? To the ground. Because we basically want to check this point. Because, since you have done all the quizzes, what you did? You have to know certain points, right? Okay, what do we have in this point, 1 or 0? Because every point has to be known to get the output at the end. If you don't know anything at the middle, you'll not be able to, you might be guessing because it's only 0 and 1, but then it will not be good forever, for sure. At least not good for the test. So, this is how we connect the LEDs to the ground. And I showed you example that, you will always have the images and things so that you make sure. And if you use the LEDs, remember, I'm sure that you probably know it, or even if you don't know, that's not a problem, because in the LEDs, you have 2 legs, right? One leg is shorter than the other one. The shorter leg will go to the ground. one side goes to the ground, right? Let's go back to the LED connections here. Just to go back. Oops. You see here, this is going to the ground. This is the ground, right? So this is basically the shorter leg. One leg is longer, other leg is shorter. Okay. So we'll be looking at all those things again and again. Yeah, technically that is negative. Yeah.
So how many circuit boards do you need? Circuit boards do you need?
At the beginning, we'll start with just one. Okay. After we will not need two before we go to lab 6.
Oh, okay.
So 1 to 5, you just need one breadboard, because what you do is you build one circuit, you record your input or output, okay, and then you demonstrate me. I'll sign you off, and then you will be building the next one, installing everything. Okay. Once I sign you off, you'll see your grade. You are done. Okay. So, but after 6, you will need 2 breadboard, because the circuit will be more exciting. So so you will need 2 breadboards after lab 6. So anyway, you will need 2 breadboards. Now what we are going to do is, since we have some idea, probably not everything, and we'll be starting the lab from the next class. So what we are going to do is, we'll go to the quiz section right now, okay, and then we'll start the quiz pre-lab 3A. In that quiz, you'll be given such images, okay, such images like this, and you'll be asked some question. Okay, can you tell me, is these two pins are connected, or which wire you want to run, or blah blah, so that you'll have better understanding of the connections, okay? Because a lot of time I have found that those things matter a lot, even if you understand the logical circuit, because at this point you have some idea about the digital circuit, because you know the logic gates, how they behave, what are the truth tables, right? How the outputs you expect. But in real life, when you are building the circuit, you have to deal with the IC, breadboard, switches. Okay? So let's go to the pre-lab 3, and just like the other quizzes, you can submit it again and again. Every time you see a little bit new questions, when you submit it, you see the right answer. So let's try those, okay? And most of the questions are multiple choice. So I know that you like multiple choice more than anything else, right? But it will be great when you see like 12 options, okay? Not 2, only 0 and 1. All right, so let's go to the quiz and see whether we can answer those questions. Pre-lab 3A.